Hello, thanks for listening to this talk. My name is Lorenzo, and this is your laptop as part of the service mesh. Today, I'm gonna talk about EnvoyFilter. I'll walk you through a problem we had at Omio, and I'll explain how EnvoyFilter helped us solve this problem. At the end, we're gonna have a demo, and hopefully you can take some inspiration home. Some questions, if you have, post them on Slack or Twitter. So let me give you some context first. Omio is a company that sells tickets of flights, buses, and trains, all under a single transaction. We integrate more than 800 providers across Europe and North America. Our developer flow is nothing out of the ordinary. People make a feature, open a PR, the PR gets to merge to master, then deploy starts from QA up to the production. Our clusters, both production and QA, are running Kubernetes and Istio. So now the problem. Today, running end-to-end tests at Omio is both not efficient and cost-effective. People are running tests today in QA, but this process is slow as it requires many steps in the pipeline to reach QA and then find out if there was a problem. Other people spin up standalone VMs where they need to go through the lengthy process of bootstrapping all the dependencies that they need for the test. So why is this process neither efficient nor cost-effective? So first, I would like to minimize time to bug detection. Ideally, I would like to run this test at PR time, or even from the comfort of my laptop. Today, we are just 3 steps away to find if there is a problem. Allow simultaneous tests, particularly if you're testing a particular service. You want to make sure you go 1 commit at a time so you don't have noise or overlapping tests. We want to reuse existing infrastructure as well. So all these services that are being bootstrapped in VMs, they're already existing in QA. So why not reuse them? At this point, you may ask, but why don't you do mocking or contract testing? At the scale of 800 providers, mocking has a high cost. Also, mocks are like any other software. They will have bugs and they'll require maintenance. So can we do better? In this diagram, we have a QA cluster with 3 services, A, B, and C. A request triggers a chain of call that hits A, then normally should go to B and then C. What if for that particular request, I can change that chain of call and make it hit B star on my laptop? EnvoyFilter to the rescue. So EnvoyFilter is a wrapper around LuaFilter. LuaFilter exposes 2 functions as the API, and they're left to be implemented. These functions are executed during the lifecycle of a request, and the name clearly tells when they are executed. We're interested on Envoy requests, and we would like to run some routing logic in there to do something with our request, to send it to B star, for example. Notice that there is the request handle there, which is a simple wrapper around the original request. So having access to the request and being able to run some logic, now the question is, who and where do we reroute? This leaves us to use the request as the messenger of this routing information. We can add this header xDevRoute with a JSON which key is the service subject to reroute and the value, the address of where to reroute. In this way, developers don't have to deploy any extra infrastructure. They don't have to change their logic in their code. They just need to add this header and the rerouting happens. Let's take a look at a pseudo implementation of our function. So you first check if the header is present and if there is a match. If there is no match with the service that this function is running in, then you just return and the flow goes as normal. If there is a match, then you take the address, you take the headers of the original request, and you make the call to whatever you need to make it. And notice that we respond immediately. So this query, this request doesn't go to the original destination, but goes to the client immediately. The only problem is that your laptop is not part of the service mesh club. This Lua code can only make calls to members of the mesh. But this is easy to overcome. We can have a dummy proxy that will be now called by the Lua code. Then it parses the contract header and makes any HTTP calls that needs to. So the big picture looks like this. Let's say we have a request that has routing information for B. So the request gets to A, there's no match with service A, then it goes to B, the Lua code finds a match with B and sends that request to our dev route proxy running in the cluster. This proxy parses the contract and then sends the request finally to B running in our laptop. Notice that B doesn't have to be your laptop. It can be also a CA agent or anything you want, as long as there is connectivity. So what about virtual services? So this can also be implemented with virtual services, but the goal of this contract was to make it as easy as possible for developers to use this rerouting feature. We didn't want them to have any prior knowledge to Istio or having to deploy virtual services and destination rules. So our checkpoint, we now can run this test from PR or from our laptop. We can have as many simultaneous tests as possible because this routing happens on a per request basis. We can also reuse all the infrastructure we have in QA and reduce costs. So it seems that we're doing good. Drawbacks. Yes, there are drawbacks. The contract header needs to be preserved all the way through the call chain. That can be a problem if there is no, if the servers don't pass the header. Let's do a demo now. So on the left side, we have a Kubernetes cluster running an echo server. Let's imagine this is B. And let's check it out. So yes, we have that echo server running there. And let's check the logs because we're going to try to hit that service. That service is running on port 3111. And we'll see how the logs do something after we hit it. So yeah, that was us hitting the server. And now we have here a Docker, an echo server running in Docker on port 8001. This echo server is the same one as the one, it's the same one as the one in the cluster. So now we're gonna make a request again to the server running in Kubernetes on port 3111. But this time we're gonna add our header. Actually, I have it somewhere here. Yeah, there you go. So notice that we add this dev route header saying when you hit echo server, please send it to Docker on port 8001. So let's try this. So you see that there is right now a request that came to the Docker server. And notice that that went through the whole cluster, hitting the Lua code in the echo server in Kubernetes, and finally making the rerouting. So some learnings. I think the adoption rate of this contract has been lower than we expected. People are, some teams are using this on their day-to-day workflow, but some others aren't because they are using gRPC mainly, and this contract doesn't support that. I think at the end of the day, we had a lot of fun doing this, and the experience is positive. And so we use Istio in ways we never thought of, and we thought it was worth sharing this with you. So thank you very much. And if you have any questions or want to try to dig in a bit more on this, please check our blog post on Medium or our reference implementation. I'll be also on Slack answering questions. Thank you very much. Bye.